Okay, well, good afternoon. I'm going to talk a little bit about virtual reality and some of the work that I do. I recently joined UCF in January. So, as a brief background, as Subir mentioned, I am a member of the National Academy of Engineering. I was inducted in 2018. And the reason why I mentioned it is not so much because I was inducted to the Academy, but it's because I was the first person that was inducted for her work in virtual reality, which I think for my field of research, this was a great recognition because VR, AR, and XR has been, let's say, officially recognized as a branch of engineering. Myself personally, people knows me because of my work with the cave and also because I have founded very large scale research centers like the Virtual Reality Application Center in Iowa State University, where we grew to be over 350 researchers and PhD students and people just excited about the technology. Then I created the Louisiana Immersive Technologies Enterprise, and that was an entity, not academic, it was a government entity to help on the recovery of Louisiana after Katrina through technology. And we had a lot to do with bringing the movie and entertainment industry, the technical development and jobs to the state of Louisiana. And most recently, I created the Emerging Analytics Center at the University of Arkansas at Little Rock, where I also initiated over there certain technology initiatives. My work has been primarily funded by industry through long-term collaborations, and that has been a very productive relationship through my almost 30 years of career. And sometimes I take a break from the academic world and I have done some entrepreneurial activities. I had the fun, I guess, of launching 5 companies. 2 of them have made it. One of them is has 400 employees and is still working today. The other one was acquired, but the acquisition allowed this our little company to be an independent unit within the larger company, so it's still functional. My research, as an overview, sits in 4 pillars. Obviously, research. My research core is virtual reality, visualization, interactive technologies. Sometimes, if the work requires, I might develop some hardware, some underlying infrastructure, and of course, a lot of applications. My work is very applied and is focused on tangible deliverables. Of course, as an academic, there is always publications, but my work always ends with a tangible piece of workable technology. I would not call it a product, I will call it a prototype, but it's something that my collaborators always are able to take and make it work, whether it is within the research groups in universities or within industry to grow it from there. My work has changed tremendously over the years because I'm always keeping an ear to the ground of what's happening out there. So we evolve as we need, and we balance, my team always balance government and private funding. And I guess we are multi or inter or transdisciplinary, whatever the current word is. My other pillar is, of course, partnership. We always become the R&D group for the small industries. In many groups, we are recognized as a competitive advantage partner to win. So for example, just recently I got word that my colleagues in Arkansas just received a $20 million grant. And that was possible because the participation of the Emerging Analytics Center. We also focus on creating a well-trained workforce on the areas of VR and XR. So our partners not only fund the research, but at the end of the research, they get the results plus the trained potential employees. We, of course, another big pillar is innovation, is trying to figure out what to do with the things that we do, how we collaborate with the state innovation initiatives, and really become a focus of activity and to some extent name recognition of whichever organization my team is part of. And of course, finally, academics, because we are embedded in a university space, so we support very much all the academic activities, the students, opportunities for the students to grow professionally. So some examples of my work is, for example, here is a virtual reality welding simulator. This was funded by the Workforce Development Office of the state of Louisiana, because welding is very critical over there and training is very time consuming and expensive. At that time, the welding simulators, The least expensive one in the market was probably in the $80,000. So our challenge was to do something that was under $5,000 a seat, and this was the result. I think with today's technology, this project could potentially be retaken and have that platform to be probably even a lot less than that. Another example is using virtual reality to train engineers on how to do field trips, which is another part that industry mentions to us, that sometimes when we go to college, we don't get enough field experience. So our research funded through the NSF and with collaborators in civil engineering and mechanical engineering, we developed an immersive trainer for field trip activities for different kinds of engineering. This is high performance computing, how to bring the world of high performance computing into the world of interactivity and virtual reality. So we got a highly intense numerical simulation running in supercomputers into feeding live a virtual space, so we could work through a developing fire. That's to get some certification of new buildings. Work related to training, these are things aspects related to military training. This is another immersive space for warehouse management, as well as equipment layout in the warehouse, as well as a conveyor system. This is a long-term collaboration. We've been working with this company now for over 4 years. Some other gadgets that we usually do, because sometimes we need to get people tired in the virtual world. Of course, we do collaborations with the humanities. A lot of these projects were funded through the National Science Foundation and some other private industries, and how this technology helps people to understand the humanities better. This is a very interesting project, how to generate virtual scenarios very, very quickly. So we do these 2D map sketches, and in less than 30 seconds, we have a full 3D immersive environment, which saves a lot for military training on creating a lot of scenarios without having to hire modelers or something. Healthcare, interactive anatomy dissection, and some other interesting trips into the human body. So my efforts at this moment, those were just samples, but really my research office is how do we bring social interaction and teamwork into VR and AR technology, and how this technology really fits, and how we can make this a really usable and affordable technology for industry. So one of my most recent projects is this one. You know, my 30 years of experience working on VR and combinations to develop the cave made us build this system, which is in the process of being commercialized. So if anybody out there has entrepreneurship spirit, please contact me after my talk today. So this is a cave, but we reduced it to a single workstation. We also made it a very, very small footprint. It's very affordable. I estimate that this thing going to market would be on the $35,000 to $40,000 for the complete system. It's very portable. It packs and unpacks in about an hour. It was designed for the school teachers to be able to, for example, check it out of the library, set it up in the classroom, do a lesson, and then pack it up and bring it back to the library. So it's really, really easy to move around. And it's very compatible with all the SDKs, like for those of you familiar with the Steam VR SDK or the Oculus Rift SDK and some of the other popular systems out there. It's great for education. You can see the kids over there having a blast in the system. And then the last piece that is really, I'm excited, and I hope to do a lot of that here at UCF, is really trying to understand how VR fits depending on not only the application, but the role of each user within the application. So here is a medical example. So for example, on the top left, you have the typical classroom setup. On the lower left, this could be, for example, a doctor interacting directly with a patient. On the middle top, you can see an instructor showing medical students how to do a procedure or anatomy or something like that. Below, you can see maybe two students reviewing the materials. You can see on the top right, maybe a doctor just reviewing some concepts, and below a team of doctors reviewing their materials. But it is the same application. These are not different applications. It is the same application, just presented differently. Here it is in a military context. So here you will have a training environment. It is the same environment, but whether you are the soldier on foot, the situation room, the drone controllers, the field commanders, the way the application is presented to you is going to have to be different. I'm very excited about this, and I hope to do a lot more of this at UCF. So to wrap up very quickly, so my research has always been in my mind what I call research with a purpose. I really like to do things as an engineer that help those around me and help my collaborators. And I cannot be successful if I don't collaborate. If I don't make you successful through working with me, then I will not be successful. So to me at this moment, on the near term, I think I would like to have some local and regional connections with industry, because I think we can very, very quickly be a good potential competitive differentiator towards large BAA responses and things like that. We can also be a potentially low risk, potentially high return introduction to the technology into your workflow, if this is a technology that is interesting to your companies. And it can, of course, develop a strong prepared workforce, you know, and this, of course, with the strong combination of UCF faculty that will allow us to together do transdisciplinary research, that we can all put together more competitive teams for hopefully larger opportunities, larger funding, and hopefully do some interesting innovations that then allows our students to be entrepreneurs. And then, of course, on the long term, I really would like to all together go after really large scale funding, like some ERC type of, some center of excellence, or very large BAA that we can all leverage each other to go for that. So with that, that concludes a super quick overview of my research, and this is sort of the diversity of technologies that I like to use. So back to Subit.
Yeah, thank you, Carolyn.